Hi, chemistry students. So this is a video reviewing our periodic table unit. So you should watch this video before you attempt the periodic table review sheet and certainly before you take the periodic table unit assessment. All right, so just real quick, periodic table. Gregor Mendeleev tried to put it together, right? He didn't have all the elements. There was gaps in his periodic table, but now the modern periodic table is based on the periodic law. This idea that there are repeating patterns within the periodic table, different pieces of information that we can glean. All right, think about it. The moon periodically is full, right? Every roughly 28 days. So it's a repeating pattern. There are repeating patterns with the physical and chemical properties of elements on the periodic table, right? So one of the first things we learned is how the groups on the periodic table, especially groups 1, 2, and 13 through 18, those elements have similar chemical properties because they have the same number of valence electrons, all right? So we also call those groups families, right? And think about it, family is important. So all of the elements in group 1 have 1 valence electron, all the elements in group 18 have 8 valence electrons, right? We skip groups 3 through 12, but so for example, group 13, 3 valence electrons, group 14, 4, right? So the group number tells you the number of valence electrons, and the number of valence electrons explains how an element will chemically bond. And the period, horizontally, the period number tells you the highest energy level, right? And that kind of explains the size of atoms. Right, so there are 7 rows on the periodic table, 7 periods, and there are 7 main energy levels, right? So an element in the 5th row would have its outermost electrons in the 5th energy level, all right? And it would have the 1st and 2nd and 3rd and 4th inside of the atom filled up, and its outermost electrons, 5th energy level. So the period tells you the highest energy level the electrons have reached. All right, now a couple of important group names or family names. Group 1, those are the alkali metals, very reactive. They explode when they touch water. Group 2 are the alkaline earth metals, also very reactive, although not exploding when they touch water necessarily. Group 18 are the noble gases. They have full octets in their outer shells, S2, P6. So they do not react, things like neon and helium, right? They do not react, noble gases. Group 17, the halogens, right? They are 1 electron away from the noble gases, so they are very reactive because they're trying to gain that extra electron. All right, groups 1, 2, and 13 through 18, we refer to as the main group elements, right? We skip the middle of the periodic table and the bottom. The middle is the transition metals. They have properties of metals like groups 1 and 2, all right? But that transition gives them kind of this weird effect where they can change their number of valence electrons. So we don't always know how many they have. And the bottom of the periodic table are the lanthanide and actinide metals, and those are not very important for us. All right, now, based on the group number, elements will either lose or gain electrons to form ions, right? So an element with 1 valence electron is going to lose that valence electron and take on a +1 charge, right? That's group 1. Whereas my nonmetals in group 17 have 7 valence electrons, they are going to gain 1 extra electron and take on a -1 charge. All right. Ions are not that important in this unit. We are going to see them in our very next unit. All right. Our very next unit is on ionic bonding. So it's good that we've seen this and we're prepared for it. But all we really need to know is a positively charged ion is a cation, right? Because it is positive. And a negatively charged ion is called an anion, A-N-I-O-N, right? Kind of looks like the word onion. When you cut an onion, you cry. Crying is negative, negatively charged, all right? So the metals form cations, positive charge. The nonmetals form anions, negatively charged. All right, now we saw 3 trends. One of them is the atomic radius, which is a fancy way for saying size. All right, so the atomic radius gets bigger as you go down a group, because you have more energy levels. Larger energy levels are further away from the center of the nucleus, right? And the atomic radius actually gets smaller from left to right because all of these elements are in the same energy level, but as we go to the right, we get more protons in the nucleus, which squeeze the electrons closer to it. It is more attractive. All right, so atomic radius, it is bigger on the left side of the periodic table, and it is bigger further down on the periodic table. All right, then we saw electronegativity. That is the ability of an atom to attract electrons, right, outside electrons. And we also saw ionization energy, which is the amount of energy to remove one electron. And they both follow the same trend. Electronegativity gets larger from left to right in a period because of the increase in the number of protons, right? The protons are what the electrons are attracted to. So having more protons means being more attractive. And it gets smaller as we go down a group because the electrons get further away from the center. So it's biggest in the upper right. The noble gases do not have electronegativity, so fluorine would have the largest electronegativity and is smallest in the lower left. Ionization energy is the same, all right? It is hard to remove an electron from a small atom. As the atom gets bigger, it gets easier. So here, since it increases to the right and it increases going up, helium would have the highest ionization energy, whereas francium in the lower left would have the lowest ionization energy. All right, and again, the reason why it gets bigger from left to right, more protons in the nucleus, squeezing the electrons closer, holding them tighter, and even being able to pull in outside electrons. All right, and why does it get smaller as we go down the group? Well, the electrons get further away from the nucleus, and there is this shielding effect, right, where the electrons are being blocked from the attraction of the nucleus. All right, so that is everything you need to know about the periodic table for your assessment on the periodic table